Hi friends, good morning. Today we are going to see about some interesting topic called Fourier transform infrared spectroscopy. Short form we can call as FTIR. At the end of the session, the students will be able to understand the working principle of FTIR spectroscopy. Before knowing about the FTIR, first you should know about the what is infrared region. Infrared region lies between the visible and microwave portion of the electromagnetic spectrum. Infrared waves have wavelengths longer than visible and shorter than microwaves and have frequencies which are lower than visible and higher than microwaves. It is divided into near, mid waves and far infrared. Near infrared refers to the part of the infrared spectrum that is closest to the visible light, and far infrared refers to the part that is closer to the micro region. Mid infrared is the region between these two. The primary source of this infrared radiation is thermal radiation. It is the radiation produced by the motion of atoms and molecules in an object. The higher the temperature, the more the atoms and molecules move and the more infrared radiation they are produced. Any object radiates in the infrared, even an ice cube emits an infrared region. According to the principle of IR, molecular vibration takes place as a result of absorption of IR radiation. That is, whenever the condition is satisfied, I mean that applied infrared frequency is equal to natural frequency of vibration. Every bond or functional groups requires different frequency for absorption, hence characteristic peak is observed for every functional group or part of the molecule. It is the most preferred method of infrared spectroscopy. In spectroscopy, IR radiation is passed through a sample. Some of the infrared radiation is absorbed by the sample and some of it passed through it. That is called transmission region. Transmitted, we can call it transmitted with the help of samples. The resulting spectrum represents the molecular absorption and transmission create a molecular fingerprint of the sample. Like a fingerprint, no two unique molecular structure produce the same infrared spectrum. This makes infrared spectroscopy useful for several types of analysis. Everybody knows the fingerprint. Fingerprint is unique for human beings. At the same time, there is a molecular structure will be there, and the molecular structure have different unique molecular structures for the different components. Components present in the sample. So, what information can FTIR provide? It can identify unknown materials, like it can determine the quality or consistency of the sample. It can determine the amount of components in a mixture. The dispersive infrared spectrometers suffer from several disadvantages like speed, sensitivity and wavelength accuracy. Most of the light from the source not in fact pass through a sample detector but lost in the narrow field. So the focusing slits only poor sensitive results, since the spectrum takes some poor results when compared to FTIR. Dispersive infrared spectrometers scan over the wavelength range and disperse the light by use of a grating. These spectrometers suffer from wavelength inaccuracies associated with the backslash in the mechanical movement, such as in the rotation of mirrors and gratings. An entirely different principle is involved in Fourier transform infrared spectroscopy, which centers on a Michelson interferometer, so that the method can also be called as interferometric infrared spectroscopy. It became a common feature in modern spectroscopy laboratories. A wide range of commercial FTIR spectrometers with very different specifications are now available. This has become possible with the availability of inexpensive microcomputers. The Fourier transform technique depends upon the basic principle that any wave function could be represented as a series of sine and cosine functions with different frequencies. Fourier transform infrared spectroscopy is preferred dispersive or filter methods of infrared spectral analysis. Several reasons. Some of the several reasons are: it is a non-destructive technique. It provides a precise measurement method which requires no external calibration. It can increase the speed. It can increase the sensitivity. It has greater optical throughput. It is mechanically simple with only one moving part. This is the simple schematic diagram of IR spectrometer, and the above one shows the IR spectrophotometer and the below one shows is the FTIR spectrophotometer. The above one shows only the gratings will be there. There is no movable mirror will be there. But in this FTIR, there are two mirrors. One is fixed mirror, another is movable mirror. With the help of the sample present in the interferometer, it will deflect the beam into two directions. So it is called the interferogram. Interferogram is first made by interferometer using IR light. The interferogram is calculated and transformed into a spectrum using a Fourier transform. That is simply called as FTIR. Fourier transform infrared spectroscopy was developed in order to avoid the limitation encountered with dispersive instruments. The main difficulty was the slow scanning process. A method for measuring all of the infrared frequencies simultaneously rather than individually was needed. A solution was developed with employed a very simple optical device called as interferometer. The interferometer produces a unique type of signal which has all of the infrared frequency encoded into it. The signal can be measured very quickly when compared to dispersive type, usually in the order of 1 second or so. Thus, the time element per sample is reduced to a matter of a few seconds rather than several minutes in this case of dispersive interferometer. Most interferometer employ a beam splitter which makes the infrared spectrum divided into two optical beams. One beam reflects off of a flat mirror which is fixed in place. The other beam reflects a flat mirror which is on the mechanism which allows the mirror to move a very short distance, typically a few millimeters away from the beam splitter. The two beam reflects off their respective mirrors and are recombined when they meet back at the beam splitter because the path that one beam travels is a fixed length and the other is constantly changing as its mirror moves. Let us see the diagram. This is a schematic diagram. The one mirror is fixed, which is called as this is the beam splitter, this is light source, this is mirror, this is a fixed mirror, this is the movable mirror. This is a detector which detects the signal. This is the lens which can focus all the light into focus to the mirror and then into the sample and then to the detector. The art of FTIR spectrophotometer is a two-beam interferometer, mostly commonly of the Michelson type. The basic optical components of the interferometer are shown in this slide. The radiation entering the interferometer is split into two beams. With the help of beam splitter. There is a splitter will be there. This is called as beam splitter. Whereas the distance traveled by beam B can be varied before it recombines with beam A. When the beam A and B recombine, an interference pattern is produced, which is incident on detector. When the two beams are in phase of the beam splitter, maximum intensity will reach the detector. The intensity will be minimum in the case the beam are out of phase. If provision is made in such a way that mirror M2 is displaced uniformly, the detector output will be a sine wave whose frequency is determined by the translation velocity of M2 and the wavelength of the monochromatic radiation, and the amplitude of the signal will depend upon the intensity of incoming radiation. If the incoming radiation is polychromatic, the detector output wave of unique frequency is produced for each component. The overall detector output as a function of time will be the sum of the waves for each frequency component. The resulting signal is called an interferogram. This means that as the interferogram measured, all frequencies are being measured simultaneously. Then the user interference results in extremely fast measurements. Because the analyst requires a frequency spectrum, a plot of the intensity at each individual frequency in order to make an identification. The measured interferogram signal cannot be interpreted directly. A means of decoding the individual frequencies are required. This can be accomplished by a well-known mathematical technique called the Fourier transformation. This transformation is performed by the computer, which then represents the user with the desired spectral information for analysis. This is sampling techniques. We can go with liquid samples or solid samples or gas samples. Liquid samples need sample diluted solution liquid cell. Solid sample neat sample, cast films, pressure films, KBR mel. Gas sample is short path cell, long path cell. The major components of FTIR: the source, the interferometer, the sample, the detector, and the last one is the computer. The source is nothing but a infrared energy which emits infrared energy from a glowing black body source, which controls the amount of energy presented to the from the source to the detector. The interferometer, the beam enters the interferometer where the special encoding takes place. The resulting interference signal then exits the interferometer. The sample compartment. The sample compartment is nothing but where it is transmitted through or reflected off the surface of the sample depending on the type of analysis being accomplished. That is where specific frequencies of energy which are uniquely characteristics of the sample are observed. Next one is the detector. The beam finally passes through the detector for final measurement. The detector used are specially designed to measure the special interferogram signal. The last one is computer. The computer is used to find the calculation of the Fourier transform with the help of some algorithms. The final infrared spectrum is then presented to the user for interpretation as well as for manipulation. Because there needs to be relative scale for observation intensity, a background spectrum must also be measured. This is normally a measurement with no sample in the beam. This can be compared to the measurement with the sample in the beam to determine the percent transmitted in terms of percentage transmittance. This technique results in a spectrum which has all the instrumental characteristics removed. Thus, all spectral features which are present are strictly due to the sample. A single background measure can be used for many sample measurement because this spectrum is characteristics of the instrument itself. The last one shows the computer. It will show the interferogram. The interferogram will given to the FFT computer, that is known as fast Fourier transform computer. The computer will display the spectrum. What are the samples present in the? What are the samples means? What are the compound present in the different types of compound present in the sample? It will display like a graph in terms of wave numbers as well as wave number versus percentage transmittance. There is some advantages of FTIR: speed, sensitivity, and mechanical simplicity. In case of speed, as I said earlier, because all of the frequencies are measured simultaneously, most measurement made in a matter of seconds rather than several minutes. In the case of dispersive measurements, so it works faster than dispersive IR spectrophotometer. Sensitivity is dramatically improved with FTIR for many reasons. The detectors employed are much more sensitive. The optical throughput is much higher, which results in much lower noise levels, and the fast scans enable the co-addition of several scans in order to reduce the random measurement noise to any desired level, referred to as signal averaging. Next one is mechanical simplicity, because the only moving mirror is the only one moving mirror in the interferometer is the only continuously moving part in the instrument. Thus, there is a very little possibility of mechanical breakdown. The two disadvantages of this FTIR: have a single beam, whereas dispersive instrument usually have a double beam. Interferograms are difficult to interpret without first performing a Fourier transform to produce a spectrum. That's all about FTIR. Thank you. We will see in the next class. Thank you, guys.